Hello, here we are starting chapter 1. I know the sections from P, the prerequisites. I think if you've never seen that stuff, it might be pretty overwhelming. There was a lot of information in one section, but that's kind of how review sections usually go. They're just kind of, they throw a lot is thrown in because it's supposed to be review or prerequisite material, but I don't think I ever saw that stuff by the time I got to college. So if you're in that boat, don't worry, it's going to get easier. Now we're starting and each section is going to have less shoved into it. The first section in chapter 1.1, we're going to talk about graphs and graphing utilities. Probably not graphing utilities so much. It's optional to talk about using calculators to graph things for us, but I know in the next semester when you take pre-calculus and then calculus, you're probably not going to be allowed to use graphing calculators. So it'd be kind of silly, I feel like, to show you that now. Yeah, and then you might lean on it too much. But I think once you get to a certain level of math, you could probably use graphing calculators. But for now, know that they're available and you can, they're there, but we're probably not supposed to use them. Yeah. Anyway, the whole point, I guess, is to learn how to graph things on our own in this class and the next class. So, okay, this might be review. I feel like this is one of those things you'll always remember for some reason. And even if you forget a bunch of math, that we have the rectangular coordinate system, we call it. There's the y-axis, which is vertical, the x-axis, which is horizontal. And we'll be seeing this a lot all through this semester, and you'll be seeing it through next semester too. We'll be graphing all kinds of different functions. Let's see. And then, of course, we say as you go up, from the origin, you have positive y values. If you go down, you have negative y values. And then on the x-axis, if you go to the right, you have positive x values. If you go to the left, you have negative x values. That's kind of the difference between left and right, up and down, etc. So like maybe it kind of helps to say that up here in this quadrant or the top right corner of this grid, we have positive x values, positive y values. Over here in the top left corner, what do we say? It's over to the left, so it has negative x values, but it'll have positive y values because it's above the origin, which is the point that's right in the middle of where the x and y axis come together. Down here at the bottom left corner, we have negative x values because it's to the left of the origin, and also negative y values because it's below the origin. Down in the bottom right quadrant, we have positive, I have to think about this, positive x values, negative y values. So anyway, if that helps, that kind of helps me sometimes. Okay, I think that looks good. So that's what we've got. Oh, shoot, I went too far. They're really going to spell it out here. Let's see. Oh yeah, that was not too far. That was exactly where we want to go. This kind of spells out what we already kind of mentioned. They're highlighting the positive parts of the x-axis and the y-axis in blue. So above the origin here, this y-axis, these values are positive. You notice it goes 1, 2, 3, 4, 5. And you could extend the axis, of course, to go higher, depending on what you need it for. You can go up 6, 7, 8, 9, however how you want. And then same thing with the right side of the x-axis. I've got 1, 2, 3, 4, 5, the positive values. And then on the left side of the x-axis and the bottom of the y-axis, you have negative values. These are -1, -2, -3, -4. You can't really see them because of the red bar, I guess that seems like, but these are all negative values. So negative numbers are shown to the left of the origin and below the origin, like we kind of mentioned on the previous page. And then positive numbers are shown to the right of the origin and above the origin. So that's something you've probably seen before, I would imagine. And I think it seems like most students remember that. For some reason, it's maybe because it's visual, maybe visual things are easier to remember. Okay, now we want to kind of talk about plotting points. If you have a point where they're specifying an x coordinate and a y coordinate like this, and those would be specific numbers, either whole numbers or fractions or decimals or negatives or zero, something. Each point in the rectangular coordinate system corresponds to an ordered pair of real numbers. So sometimes we call it a point, sometimes we call it an ordered pair. I guess graphing it as a point on the graph, that's a point, but the ordered pair, when you see it looking like this, x comma y, we call that an ordered pair. The first number in each pair is called the x coordinate. So the number on the left is the x coordinate. It denotes the distance and direction from the origin along the x-axis. Of course, if it's a positive number, I would go to the right. If it's a negative number, I would go to the left. The second number in each pair, called the y coordinate, denotes the vertical distance and direction from the origin along the y-axis. So the same kind of thing. If the y value is positive, I go up, and if the y value is negative, I'll go down. So nothing too exciting so far. Let's see what else. Did I go too far again? Let's see. Nope, looks good. All right. Example, here we go. Plotting points. So it's kind of already done for us, but that's okay. Here's a point, -2, 4. The number on the left is always the x value, and the number on the right is always the y value. And if it's kind of new for you and you've never seen this before, just remember alphabetical order, left to right. X or Y, which one comes first in the alphabet? That's kind of the coordinate that's going to come first too. So I need to find -2 on the x-axis, which, as they kind of show here, the red arrow moved us to the left 2 units to -2, and then the y coordinate is +4, and the positive direction on the y-axis is up. Here's 4. So you kind of match the x value you want and the y value. Where would they meet in a point off in the grid? It would be there. This is the point -2, 4. So not too bad. Yeah, and then again, as they use this word over and over, the origin is just where the x and the y axes meet, origin. And it's just the ordered pair 0, 0. You don't move anywhere left or right. You don't move anywhere up or down. It's just right there at the origin. Okay. Now let's plot this other point. We've got 4, -2. It's kind of already done for us again, but if you want to practice, you can always make your own little grid over here and say, okay, 4, which way? That's the x value. I want to go 4 on the x-axis. That's a positive number, so it's over on the right side. There's 4, and then -2 is the y value. On the y-axis, 4, the negatives are down, so I go down to, I should have put the 4 up here. This is about where they meet, something like that. And for sure, on a midterm or the final, if your point or graph doesn't look perfect, I'm okay with that. I know on a computer it's easy to do it perfectly. Like here, someone created this graph on a computer, but as long as it looks like it's in the ballpark. If you said this is 4, -2, and then you look at it and say, wait, it kind of looks like it's a little too low or a little bit too high or a little bit whatever. I know yeah, we all, nobody's perfect. We're not robots over here. Okay, how about now graphs of equations? Now we're going to get into the kind of a little bit more complicated parts of this, but still pretty okay, I think. Talk about graphs of equations. A relationship between two quantities can be expressed as an equation in 2 variables, such as y = 4 - x squared, for example. In chapter 3, we'll really nail down how to graph these types of guys. Yeah, a solution of an equation in 2 variables, x, y, or x and y, is an ordered pair of real numbers with the following property. When the x coordinate is substituted for x and the y coordinate is substituted for y in the equation, we obtain a true statement. So let me just throw something in there. If you think about it, I can let x be anything I want here. X be anything, because I think it was the previous section P something 6 or 7. My memory's so bad. One of those where we're talking about rational expressions and we found their domains. And I think we pointed out the only bad thing that can happen is if you have a 0 denominator, that would be bad, or imaginary numbers. But that's not going to happen with this equation here. There's no way I can get an imaginary number because there's no square root, and I couldn't get a division by 0 or a denominator of 0 because there's no denominator and there's no division. So x can really be anything, and then y is predetermined at that point. How do you spell that? Determined? That's a lot of e's in one word. Anyway, determined, something like that. So if I just let's say let x be 1 or something, just for fun, because I'm boring and I don't like to make up interesting numbers. Okay, what would y be? 4. I would just, insert whatever I want for x. Oops, why did I do 2 parentheses? I don't know. Don't worry about that. Then y would be 4 minus, instead of x squared, I'm putting 1 squared. 1 squared is 1 times 1, which is still 1. 4 minus 1 would be 3. So there's an ordered pair that is a solution to that equation, is a solution to that equation y = 4 minus x squared. Because if you substitute y = 3 and x = 1, you're going to get a true statement. It's going to say 3 = 3. And then that value that I chose, x = 1, that wasn't really special. I'm just a boring person and I picked boring answers. You could have put 0, you could have put a negative number, you could have put a fraction, and there would always be a y value that would be associated with it. So these equations like this have infinitely many pairs of solutions, or just infinitely many solutions. Infinite number of solutions. Yeah, because like I said, there are infinite number of values I can replace x with. And then there's a Y value that gives that, that you can find just like we did over here, that would make it a true statement. So because there are an infinite number of solutions, if someone said, okay, give me all the solutions to this equation, that would be impossible. I could not list the infinite number of solutions. My life is not infinite, so I would run out of time. So that's kind of why we graph, because there's an infinite number of solutions. I can't list them all. I'm going to graph just to represent those infinite solutions, to represent the infinite solutions. And there are other reasons we learn how to graph too. There are things we can do with the graph, and it tells us information we might need. But that's kind of the reasoning behind it. I can't, before in previous sections, we would say, okay, solve this equation. And there'd be one solution, maybe two at the most, usually. But these ones, there's infinitely many. So, and right now we don't maybe necessarily know how to graph this guy, but we'll see coming up in the future in chapter 3 here, we're going to learn how to graph this guy. This is a parabola, a downward parabola, kind of like a U shape, upside down U. That's what this guy would look like. Y equals 4 minus x squared. And it has arrows pointing downward because it's letting, you're letting this graph go down to infinity. So there are infinitely many points on this graph. I can pick any random point I want on the left branch, the right branch, but all the points on that graph represent the infinite solutions to that equation. I can't list them out, but I can draw a picture of them, I guess. That's the idea. Sorry, let me went in too much detail on that. You guys probably tuned me out or already went ahead in the video and just ignored me. Oh my God, here she goes babbling on again. Okay. Now it's graphing an equation using the point plotting method. So here's an equation, y equals absolute value of x plus 1. I didn't really talk too much about absolute value, so maybe I should talk about that real quick, just in case. Absolute value, you may have seen it before, maybe not. Doesn't come up too often, but it's all of a sudden when it does come up, we're all expected to remember what it means. It just makes any number positive. That's all. That's kind of the idea. Makes any number positive. So if I had the absolute value of 2, well, that would just be 2. It's already positive. Absolute value of -5, that would be, well, make it positive now. It's 5. That's literally all it is. You just take any number. It could be a fraction too, like -2/5. Why'd I do negative? How about -2/3? That's more interesting. There we go. It was negative. Now I'm making it positive. That's really all it is. Or like even the square root of 7, whatever that is. Well, I don't know what the square root of 7 is, but it's a positive number. So I don't need to change the sign. It's not negative. I don't need to make it positive. It was already positive. That's really all it is. It seems more complicated than it really is. So that won't be so bad. Let's see. Yeah. So they're saying if we want to learn how to graph, this is probably the best way to do it. If you're given an equation and someone says, okay, graph all the solutions. Like obviously in this one I just drew it, but maybe we don't know how to do that yet. But if you have no idea how to graph something, the best thing to do is just kind of start listing x values, make a little table of values maybe, and then fill in x and then go find y. Sort of like we did over here. I only filled in one x value over here, x equals 1, but I could have had more if I wanted to. But they're saying, select integers for x starting with -4 and ending with 2. So I'm going to keep, and integers are like no fractions, no decimals, just whole numbers and negative whole numbers. So -4 all the way to 2, -3, -2, -1, 0, 1, 2. Those are the ones I want. And I kind of have to do some work to figure out what the y values are. So I might need a little more room here, but oh, what happened? There we go. It popped out and it popped back in. Our equation is y equals absolute value x plus 1. I'm going to replace x with first the smallest x value that they told us to use. So I'll replace it and then see what happens with y. For x equals -4. Okay. What will y become? This is something a little bit weird because there's 2 numbers inside the absolute value. We have to treat it as a little bit special. So negative, instead of x plus 1, now it's -4 plus 1. I can't take their absolute values separately. I have to combine the 2 numbers first, and then I can take the absolute value. So it's kind of like order of operations. I have to do -4 plus 1 is -3. All right, and then I'll take the absolute value of that. What's the absolute value of -3? I'll just make it positive, and that's it. So that must be my answer for that guy. So that means that there's an ordered pair, -4, 3. That's a solution to this equation. Or in other words, it's a point that's on the graph of that equation. Now I'll try to do it for all the other values. And you know, don't feel like you have to show a lot of work. I'm gonna try now. If x is -3, what's y? Y, according to this equation, it's x plus 1 absolute value, but I want to replace x with -3 this time. So first I replaced it with -4. There we go. And then we saw what happens, but now I want to replace it with -3 here and simplify it down. Once you feel comfortable, you can always do this in your head too. This part I'm writing out, you don't have to write it out if you don't want to. Just be careful if you do it in your head. I'm going to combine the numbers inside first. -3 plus 1 is -2. The absolute value of -2 is +2. So that must be the y value for the other point, or the second point. And these are all corresponding to ordered pairs. So far I have ordered pairs of -4, 3. I just found another one, -3, 2. Seems like there's a pattern here. I feel like as our x values are going up in value, our y values are going down in value so far. Let's see if that keeps going. Okay, we did that one. How about -2? I'm kind of jumping around, just finding room where I can find it. X is -2. What would y be? Y was absolute value of x plus 1. Let me see if I can replace x with -2. Okay. Y is absolute value x plus 1, but I'm going to replace x with -2. Let's see. Yeah, feel free to do this in your head. You don't have to write this out if you know, on a midterm or whatever, no worries. -2 plus 1 is -1, and the absolute value of -1 is 1. So that would be my next value here. All right, we're getting there. And yeah, maybe as we go, you might feel more comfortable. I'm gonna take the x equals -1 and throw that in there. Okay, my y value should be absolute value x plus 1. Let's see. And x is -1. So I'm going to replace that guy here. Yeah, I guess it depends. If you're trying to be really careful because you're taking a midterm and you don't want to mess up or something, yeah, you might want to show your work. But if it's a homework problem, you can always try it and then see what happens. Okay, inside those absolute values, I've got -1 plus 1. That would add up to 0. So that's kind of interesting. The absolute value of 0 is just 0 because 0 is not negative. It's kind of not really positive either, but it's definitely not negative. That would be my next value. I'm going to throw that back in there. Okay, we got 3 more. How about now x equals 0? We're replacing. Okay, that was 1. And now, again, we're going to replace it in absolute value x plus 1 equals y. This time x is 0. We'll see what y ends up being here. There's x, but he's going to be replaced with 0. 0 plus 1 is 1. And the absolute value of 1 is just 1 because it's already positive. It's like I'm looking at it to see if I need to change it to positive, but if it's already positive, no need to change it. I'm going to put that in my table there. 1 corresponds to an x value of 0. Okay, 2 more. Let's see if we can do this. X equals, they give us a lot of these to do. X equals 1. If x equals 1, y will be absolute value of x plus 1. All right, y is, and then x is 1. Replace x there with 1. I need to add 1 plus 1 now, and then I'll take the absolute value of that. Looks like the values inside the absolute value are getting bigger. So if they're positive, they're not going to change. Y equals 2. There we go. So that I'm going to put that in my table there. Bada bing, bada boom, and then we got 1 more. I know you probably don't have enough room on your paper. Sorry. I get to cheat and make more room. For x equals 2, y is going to be absolute value of 2 plus 1. Let's see. Okay, 2 is going to go here. 2 plus 1 is 3. Looks like inside the absolute value I have 3, but you know, the absolute value of a positive number is just the same number. So I'm gonna, if I barely can fit that, I put that in my my table. All right. Okay, so we found all the values. Let me leave it there for a second just to show it. All right, we got it. It looks good. Now they want us to plot it. Okay, I have all my points really high up. Let's see, what do we get? We had -4. I'm going to write them down here. -4, 3. That was the first point. -3, 2 was the next point. -2, 1. And then we had -1, 0. Let me make sure I'm doing this right. Yeah, okay. And then 0, 1. 1, 2, and 2, 3. I think those were the values we found so far. That's all we need, I guess. So let me see if I can plot those points, and then that's the idea, is like plot all the points and then see if you can find some kind of, I don't know, pattern. What kind of shape does it look like it's taking on, sort of? All right, -4, 3 would be up here. That's my first point. Done. -3, 2 would just be just to the right and down from that one. And then -2, 1 similarly would be to the right and then down 1. And then same thing for -1, 0, it's to the right, down 1. The next guy is 0, 1, that would be right here. Oh, now we're moving up. Ah, look at that. I thought they were going to be going down, and they're flipping the script on us. 1, 2 would be here. 2, 3 would be here. So it almost looks like a V shape, and then we'll find out later in chapter 2 that that's exactly what shape these types of graphs have. Absolute value graphs look like a V, yeah. But we wouldn't have known that necessarily, right? I think we did all the points. Yeah, so that's probably what we would do if you are asked to graph something and you have no idea how to graph it. Just throw in some X values. Usually keep them kind of close to the origin, just because that's usually where all the action's happening. Yeah, and then if you're not sure still, you look at the graph and say, oh, I can't really tell what shape this is. You can always plot more points. Say, well, what about if I throw more X values in that are smaller in the negative direction or bigger in the positive direction? Yeah, and that should work. Okay, the next thing to talk about as far as graphs go is one of the most important parts of the graph of an equation is the x-intercepts or the y-intercepts. And it's a good name because it's exactly what it sounds like. An x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. The y-coordinate corresponding to the x-intercept is always 0. So that's the idea. Let's see. So x-intercept, it always looks like something, 0. Because if you think about it, let's say, maybe just that same graph we saw above here. Let's see. Boom, boom. X-intercept, that would be this point. It's where the graph is hitting the x-axis. And I think if I remember right, it was -1, 0. Yeah, because if it's on the x-axis, your y value would be 0. You're not above the x-axis where you would have a y value that's positive. You're not below the x-axis where you would have a negative y value. You're just right on the x-axis. Yeah, and then similarly, and yeah, no matter what your graph looks like, the y value of your x-intercepts will always be 0, no matter what. And then how about, on the other hand, the y-intercept of a graph is the y-coordinate of a point where the graph intersects the y-axis. The x-coordinate corresponding to the y-intercept is always 0. So in the graph that we plotted earlier in the previous slide, this guy, I think it was 1, 0 is that point, if I remember right. That would be your, oh no, sorry, I mixed them up. 0, 1. You're not going anywhere left or right. You're just going up, which is the y value. Come on now. Yeah. So that, oh, what did I do? Oh, geez. Oh my gosh, I'm sorry. What is happening in my life? Da, 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 da. There we go. That's how it will always look. 0, something. Because if you're on the y-axis, you didn't move left or right off to the x-axis. That means his x value would be 0. So here's another graph. I kind of have the intercept boxed just to make it really easy, but this is our graph. It's a line. Okay, boom, boom. And we'll look more at lines in chapter 2 for the most part. Maybe a little bit in this chapter as well, but we'll definitely nail it down in chapter 2. So there's the graph of a line, and they want to know the x-intercept and the y-intercept. So the first one, x-intercept, is where it hits the x-axis. The x-axis is the horizontal axis. Why do I always get those mixed up? The horizontal axis, x-intercept, would be, where is that hitting the x-axis? Well, it's like we said, the x-intercept always has a y value of 0, but it looks like it's hitting the x-axis at -3. That's the x value, I believe. Okay, then the y-intercept would be this guy, this 5. Is 5 the x value or the y value? I always mix them up for some reason. No, 5 is the y value. We said for y-intercepts, the x value is always 0. Looks good. That's it. Yep. That's all they want. That's pretty nice. All right. So how about intercept information given by graphs? Okay, what kind of information can we get from intercept? That's a good question, right? Let's see. Okay, here's an example. Oh man, it's always a bummer every time. It's always talking about rats dying of cancer and I don't know, whatever. Divorce rates are considerably higher, I can't say that word, for those who marry younger. Oh, thanks for starting my day out right. That's a bummer. But education may also play a role in the longevity of marriage. What? The equation D, man, why can't they use X and Y? Come on. D equals 1.8 N plus 14 models the percentage D. Okay, you could use P for percentage, but that's fine. Of marriages that end in divorce after N years when married with a high school but no college education. Okay. Okay. Okay, so what is it? D is the percent of people that get a divorce? Is that what they've meant? I think so. Okay, so D is the percent that get a divorce after N years. So N is the number of years that have passed. Okay, okay. I guess I kind of understand that. There we go. That kind of helps me. I don't know. I have to kind of write things down as I do these things. Okay, what do they want us to do here? Determine the percentage of marriages ending in divorce after 15 years for high school graduates with no college. That last part, when they say for high school graduates with no college, they're just saying you have permission to use this equation because this equation was only true for those that are high school graduates with no college. So they kind of had to throw that in there because someone might have said, well, I don't know what it is because you didn't tell me what kind of people these are. This equation only goes for the people that have no college, but a high, blah, blah, blah. Yeah. But it looks like what's going on here is they gave us 15 years. What is 15? That's N. So N is 15. I think that would mean just, I can take this equation, D equals 1.8 N plus 14 and replace N with 15. I had to make sure I was saying that right. Yeah. Okay. Replace N with 15 in the equation given. D equals 1.8, and it should spit out the percentage of, what is it? Percentage of, I can't even say it. The marriages that ended in divorce. Yeah. There we go. Okay. All right. Then maybe there'll be less of a bummer problem here. Okay. Let's see if I put 15 in there, 15 is going in where N was, but everything else is staying the same. So D is on the left side. Okay. And then 1.8 times. And now that they're multiplying, I have to put one of those in parentheses or put some kind of multiplication symbol because it looks like 1.815. I got to put multiplied by, either indicating it by parentheses or some little multiplication symbol. All right. And usually like in real life situations, they're not going to be nice, pretty numbers. So I can't multiply 1.8 and 15 in my head. And I'm too lazy to write it out, and do it the long way. So I use a calculator. I mean, even though we're not supposed to use a graphing calculator, I could still use a little, little calculator to multiply. So I think 1.8 multiplied by 15 is 27. And now I'll multiply 27 by, or sorry, add 27 and 14 to get 41. All right. Usually at this point in a word problem, I always forget what I was doing. I'll say, okay, 41, all done. Wait, what was that again? What was I even trying to find? That's right. That means 41. This is a good kind of rule of thumb when you're doing word problems, is to kind of declare what your answer means, and like in a sentence. 41% of oh my gosh, it's going to be a mouthful, but I can't even. Marriages, and I don't know. You can probably phrase this a lot of ways. In divorce, after 15 years, because that's the number of years they specified here. For people, I should just say for high school graduates. I don't need to say people with high school diploma, high school graduates with no college education. Yeah. Education. When I say with no college, it makes it sound like they don't own their own college. I don't mean it like that. I wish I owned my own college. That'd be pretty sweet. Anyway, that's it. All right, there you go. It's funny. It's interesting how they determine this stuff too, right? Like they must have had a bunch of data, just all these marriages, and okay, well, seems like this is the pattern. Anyway, I think if you take statistics, you'll learn how do they come up with this type of equation, because that seems kind of weird. Did someone just make that up and pray and hope for the best? Hope they were right? I think they take a bunch of data points, like how many years people have been married and whether they got a divorce or not, or how, after how many years, and then they can come up with that equation using some kind of statistics type fun stuff. Anyway, sorry to bum you guys out. Maybe the example in the next problem will be a fun one, like picking flowers in a pretty field, or how many birdies are sitting on a wire and singing songs. That sounds better. Okay.